Okay, so for the ordering of the, I kind of just have it in the survey, so maybe we'll go through the order. I'm gonna call off the teams. I want to make sure I'm not missing anybody. So I have Polite, Traffic Shifters, Maintenance Notification, the BMP Collector, IXMon, and Peer Validators, or Validation. Is that all the groups? Raise your hand if I'm missing somebody. Brandon's also going to present at the end, but he can't win, so he's not in the list. Sorry, Brandon. All right, cool. Aww. All right, so first we'll have Polite come up, policy tool for engineers. So if they want to come on up. Also, at the end of this, we will be doing the voting on the different hacks, along with some raffle prizes. So watch out for that.
Does anyone know how to share something on a Mac? Because I have no idea.
What do you want to do?
Just put this on the screen. Yes. Thank you. Yeah, got it. Right. Hello, everybody. I would like to get the others as well to come up who was going to present. We ended up having about 12 people in our team, and everybody's just kept coming and coming, and they were interested in, so I didn't want to say, go somewhere else, which means 12 is really difficult to manage in a small hack. So we divided up into 4 different groups, and everybody is going to present their piece of module, what we did today here. So the idea was to create a tool which goes out to registries, pulls the prefixes per ASN, and generate configuration templates and push down to Juniper and Arista devices. And we were quite successful, so we were happy by the end of the day. I also worked on a little stats module. So I just go through quickly of the structure, and then everybody gets to present their bit. So we've got a collector. It goes out to Arin. It also gets some parameters which ASNs we are interested in. This is going to be the list of the customers. Create a JSON file. The teams are agreed between the interfaces of how they're going to use those data. And then we created templates. And there's 2 different groups who worked on templates. There was one for Arista using a eAPI. And the other one was some other tool. And then created config files, which got down pushed to devices in different methods. I just present my bit first for the statistics. So if you do this tool in production, it will take some time to do so and some resources. And it's important for management to understand what they can win with this tool. So just created a quick JavaScript tool to show you what you can win with it. So for now, we have 4 peers. You can't really see, but the AS numbers and the customers now names aren't there. The last one is Microsoft, and it shows you how much prefixes you receive from it today, which is over 1,500. Others were not that significant. And then the other one shows you how much it changed since April. So you could see Microsoft had an extra 10, this one extra 7, this one extra 5. If you've got multiple instances is changing, you need to create a change request, you need to create follow some processes, which takes up time. If it's done automatically, you save time and money. Thank you very much. The next one is the data team.
So our team was responsible for writing the piece that actually collected data from, we ended up using RADB. We were disappointed to find that there is no nice RESTful API for this. So we ended up using Whois and grabbing the data that way and collecting it together, putting it out in JSON format for the next team to use.
So we made the Juniper templates. We made use of Jinja 2, as well as we got the JSON files from the data team, and we picked out all the prefixes that were advertised by the particular AS that we were looking into. And accordingly, we made the BGP policies for us to accept routes from that customer. And then we pushed it into configurations for the devices.
All right, and then once the configs were ready in you know JSON format, once the config were ready, I gave those configs to Vadim, and then he just used the Juniper PYEZ API, the netconf API that they provide to do management on their devices, and based on that, he just committed the configs, and he also basically assembled everything that all the crappy code that I gave him and put that in place.
And I'll speak on the behalf of the Arista template team. They did it in the same file. They got the JSON data, and they used the Arista E API to connect to the Arista device and push the config over. So very similar to what we did with Juniper, and both of those tools seemed like a good thing to use, definitely better than NetMiko, because it's we couldn't merge configs together in an elegant way. Using APIs was definitely a good choice for us, I feel like. Thank you.
Just I have to say thank you to the guys because they did a fantastic job because so many people and then we just could pull it up together by the end of the day. So it was really successful and thank you very much.
Thank you. So next we have the traffic shifters, the only one with a name that's, I like it, but let's just go from there. Who's gonna present? Awesome.
Okay, so while she's setting up, just to let you know, we've run into quite a few scenarios where we're trying to upgrade devices in our network, and if you're at a hyperscale network, you know that trying to do that manually is an absolute nightmare. So what we've developed is a program that will go through and upgrade, basically in a clause type architecture. We'll go through and shift traffic from either A to the B side. If you're Oh, here we go. Okay. So from the A side to the B side so that you can upgrade the A side, and then run health checks, make sure that everything's good, post upgrade. And then we'll shift traffic again from the B side to the A side so you can upgrade B. So we worked on a process to essentially shift traffic from A, upgrade A, and then shift traffic back onto A so that it all is good. So we didn't complete it in upgrade B. We're just doing A at this point. That's all we could get done.
Yeah. So here's moving traffic. Yeah. Sorry. So here we're moving traffic off. It's a command line tool. You specify your host name, your user, your pass, the action, which is either move off or move on, as well as the devices that you need to check to actually confirm that those routes are withdrawn or on there. And so it just runs through, it tells you it's connecting to the route. So that's so 52.24 is the VMXs in our network topology. And then it's checking all the 10 dot addresses, or those are the spines. So it's actually checking and it confirms that traffic has been moved off those devices. And then you can run your upgrade on that specific device, which takes a little time. Once that's complete.
Look how fast it took to upgrade. I mean, that was part of my code.
And now we're going to go ahead and change this to move on.
By the way, one thing to mention too is that the Junipers are advertising a default route to the spines, the Arista spines. Okay, so that's basically how we're shifting the traffic. If A side is no longer advertising, then traffic's not going to take that path when it egresses out to the internet, right, to the edge. So when we move off, we stop advertising the default, we upgrade, then that device that needs traffic again will just start advertising the default to this spine layer.
Yeah, so the check is to actually see if the defaults are there or not, to verify that traffic has been moved, so.
So then,
Yeah, and it's actually mostly functional. This works. You can do this. Like it's actually moving. Like this is actually confirming everything on the router. So
so yeah, it would just reverse the process for P. So we just got a really rudimentary upgrade process done.
Thank you. So I think the next one, I probably should have just said this ahead of time, but next we're gonna have maintenance notification, and then just so people know, the BMP controller, IXMON, and peer validations. So here we go. There. Here you go. Whoever's gonna talk.
Hi, how's it going? So I am Colin McIntosh, and
I'm Matthijs Jonker.
and we're going to talk about maintenance notifications and how to manage them better. So for our hackathon project, we had some goals of we want to be able to read maintenance notification emails, and we're doing that over IMAP. We want to identify which emails are maintenance notifications, and then parse out the start time, end time, the circuit ID, and like the partner name. Then we want to add those events to a calendar, and then we want to notify people if there's conflicting maintenances. So this is a little bit of how it works. Like I said, it connects via IMAP. We wrote the whole thing in Python. It just reads in your emails, finds maintenance notifications, posts the calendar events to Google Calendar via the Google API, and then if there's a conflicting notification, it will send an email, not via the Google API, via actual email. So how it works is there's some already existing work on maintenance notifications for parsing them out via iCal and a header called X maintenance note. So we wanted to try this first because it's more standardized and easier to parse. The problem is not many vendors actually send these headers or the iCal attachment. We only have one vendor that does, so it doesn't really work that well. So our fallback is naive parsing, which is just some regex patterns to match an email, a domain, the start and the end time, and the circuit ID. And basically, it's just one of these little YAML blobs for each vendor and the type of maintenance notification that they send. So it works. It actually posts it to Google Calendar. This is an example of what one of the notifications looks like. It's very simple. Of course, we can add more data in here. I actually want to add it so that way it has the original maintenance message in the description, but we didn't get time to do it. Yeah, and this is just some future work that we think would be cool to work on. We'd actually like to check the circuit IDs against a topology and see if the conflicting maintenance is on the same path. Right now, we actually just check if it's during the same time, which is very naive and won't work very well. So we need to improve that. We'd like to add support for the X maintenance note headers. Right now, we're only doing the iCal parsing. Like to add more vendor patterns. It would be nice to be able to support other types of maintenance like power maintenance or site maintenance just to get it on the calendar. Circuit ID validation, which goes into the topology checking. And then we also want to ask vendors to actually include the X maintenance note headers because that would be awesome and make this much easier to do. Yeah, that's pretty much all we got.
That's it. Cool.
Yeah, that's it.
So as you mentioned, Colin, the libraries that already exist are in Python, and Jade and I were working on re-implementing those in Go, which was quite interesting for me as I'd never used that language before. And we made some pretty good progress. We got the examples duplicated in a very hacky way of taking iCal data, generating JSON for that, and then on the other direction, taking raw data and then generating the iCal in Go. And then Jade did a bunch of work to start putting that up on GitHub and cleaning it up a lot. So a lot of good progress today.
Thank you. So next we have the BMP controller group. So if you want to come on up and present what you have.
Okay. Cool. Okay, this is on. So let me kind of explain what we were trying to do in the first place. There was quite a lot of stuff that we actually had to finish to try and see if we can piece this together. I think we're sort of halfway there, especially in terms of getting most of the routes that we need into a Redis database. We'll sort of explain some of the pieces that we were working on. The primary goal was I can have as many routers as I want in my BGP network. And the primary goal is to make sure that each router does not actually push any routes into the RIB as part of the BGP process itself. Instead, the BGP processes on all of the routers are only used for establishing the neighbors and, of course, getting the routes here and there based on what's required. But the actual route calculation and the RIB creation happens on the collector front. So what we effectively do is when we learn routes over, let's say, from router 2 into router 1, we publish a single route policy on router 1 to prevent any routes from being downloaded into the RIB and push all of the routes into the OpenBMP controller that's sitting up top. Now, because all of that is being published into a single Kafka bus, we effectively have multiple sort of agents pulling data off that bus and then processing all of the RIBs that we would need one by one. What we have at this point, at least working, is the fact that we are able to get the adjacency in RIB completely populated from the router 1 as we receive all of the routes over OpenBMP, and then go ahead and push all of that into a single Redis database. So as that happens, we have two other pieces of code that we haven't finished integrating yet, but those pieces of code effectively will allow us to have completely sort of Pythonic versions or YAML-based versions of defining a route policy so that you can define exactly what goes into the adjacency in RIB post policy, and then finally do path selection and push everything down. So the last portion is the one that we wanted to concentrate on separately, which is how do you actually get the routes into the RIB eventually? We're going sort of a roundabout way of getting the routes into the RIB. So they will appear as, in this case, static routes. The admin distance would be set completely based on whether it's an iBGP session or an eBGP session. So the static routes can effectively be monitored in that way. And once you do a redistribute static, your adjacency out RIB just gets populated based on what the controller published. So effectively, we're using BGP only to establish neighborship and learn routes, but we're actually doing the entire RIB calculation and creation into a Redis database up top in the controller. So I was making a few last minute changes, so I hope I didn't break my code, but let me see if I can show this. Right. Okay. So, damn it. Yes. Oops. Sorry. 1 second. Yep. Okay. So, sorry. Right. So what you actually see here happening is that as the routes are being learned from router 2 onto in through OpenBMP, we're pushing all of that into the Kafka bus, and that's being learned by the threads running and effectively looking at the Kafka events coming in. What you're noticing here is that as each of the routes come in, we're able to sort of immediately understand whether they're add or delete events for each of the prefixes, and we create an entire rib tree for all the routes coming in. The way we at least try to monitor all of the routes is to make sure that we create a tree for the routes. I don't want to get into details of all of the code, but effectively we are mirroring what BGP would do on the router, but do it on the controller only in terms of rib creation. We don't handle updates, BGP updates. We don't handle neighbor messages, etc. So instead of re-implementing a controller which basically does peering with all the routers, we only concentrate on RIP calculation and let the peering and everything be happen purely on the routers themselves. So we're not re-implementing the protocol. We're just allowing ourselves to completely deconstruct all of the ribs in BGP so that the user has complete control over what goes into each rib that BGP handles, which are 4 of them, right? Also, if I can just show you another part of this. So, so in case somebody still wants a CLI, the CLI will now be Redis based. You can effectively query all the keys as you need and try and figure out exactly what's happening in each rib. You can, of course, construct your own sort of CLI on top of it by creating a Python client that queries this and figures out what you want to do with each part of this. In this case, since I've only populated the adjacency in rib, I'll show you what it looks like. Okay, last part, which is as I mentioned, you'll get all of the routers that have been pushing the data into the OpenBMP collector, along with the hashes corresponding to each of the routers. And once you take a look at any of the data as it keeps coming in, what you notice is that all of the routes being learned are effectively pushed in to a separate JSON rib, which in this case is the adjacency in rib. And as you continue to populate each of the pieces one by one, you will notice that each rib gets populated one by one as a separate JSON entity. So this helps us also isolate all the pieces of code. So as you go ahead and provide your own logic for route policies or own logic for path selection, we can do that, or we can fall back to normal BGP path selection and route policy concepts. So in a way, that's sort of the gist of it. We weren't able to complete the whole thing, but I think we can probably do it later as well with plugins. All right, thank you.
All right, thank you. So next we have IXMon. So whoever's presenting for IXMon, please come on up. I think you're split into kind of 2 groups, but you can just both come up and do it at the same time.
All right, so we just grabbed an item off the list. I'm not sure who added it, but whoever did, thank you. It was measure WAN link latency router to router and check for changes. So we took this and tried to apply it to peering exchange. So we set up a Django backend. So you could actually create router objects, define exchanges, and authentications for all your different devices, as well as peers and track polling from your edge device to the other peers. So the idea is we used the PYEZ, and when you send a poll, it'll actually log into the device and then poll whatever peer you like, and then measure the latency and record it back into the database. Based on that, you could take some other actions. If you're seeing spikes in latency to certain peers, you could automatically tear them down. If you're seeing spikes to certain peers on the exchange but not others, it might help you identify some congestion issues or something like that. But we never got to that point. What we did get to, so you can go into the database and define your objects and methods of authentication and exchanges and which routers they actually sit on. And so you can send polls from a device to another peer that it's connected to on the peering exchange. And it will get that data and populate it back into the database backend. And you've got your ping, min, max, and average. Those values have to be divided by 10. 1,000, sorry. And you can see each one. The idea was to also take this data and maybe put it into Plotlib so you could graph it based on a specified range, but we ran out of time and didn't get to do that. You want to talk about the one you did? Different exchanges? No? All right. Yeah, I'll go to that one in a sec too. So another one we did was if you're in a situation where you peer at multiple exchanges and there's another ASN that's also at multiple exchanges and you have sessions with them at some exchanges but not all of them. It'll run through the different exchanges that you both have a presence at and see if you have a peer session configured. And then if not, recommend that you set up peering at that exchange. And the idea was to even automate that into like an email template from PeeringDB. So just send off a, hey, we're both here. We already peer at the following exchanges. Would you like to set up peering? Something like that. We got part of it done. So it grabs data from PeeringDB, and it grabs data from this backend here as well. So we got peering set up with Microsoft at the Seattle Internet Exchange, and it grabs all the Microsoft ASN data from PeeringDB, and it runs through the list and sees that we have peering presence at 6 and AM6, but we're only peering with them at 6 and not AM6. So at this point, we would have liked to write the code to raise the recommendation to peer with them at AM6 as well.
That was it. Thank you. So peer validation. I don't actually know the right name, but we're going to go with that. And you can correct me when you get up here. And then after that, we'll have Brandon. And then after that, we will do some voting.
Oh, you have it on. Should I bring mine? Yeah. It's in my hand. You have it. All right, so we weren't able to complete all the way through. It was 3 of us, and mainly what we were trying to do is with the smallest amount of input, create a source of truth. On that source of truth, basically have a model created for
for every given device. I have an example device from here. Just went through and did it with XML since I wanted something that would persist locally. And from, if you want to show the small amount, like the actual input that generated that. Yeah. So basically it's a CSV that would basically be the name, vendor, PID, the exchange it was at, and what state it was in. Really what happens is by the end of it, what we wanted to do is expected versus actual validation. So where state validation was always the intended target at the end of the day. So active being the device is actually in production. And from that, then you'd be able to consistently through the Jinja templates alter whether it was in a, if it's in a prod state, then it would be in a pushing traffic in a non-overloaded state. And if it was in a drain state, it would be like maintenance or incident or pre-production, anything like that. I'll let Ashley talk about his part with the templating as well.
Sure. So I started out trying to solve all of the world's problems and didn't think of this very hacky and thinking it was like a final production design. So I had like 10 different Jinja models and nesting, and then by the end I had 2. They were very like 20 lines long each. So in the end I did get towards the end, but we ran out of time to actually integrate the data source with the Jinja, but they both do exist. It's a matter of just unifying the namespaces. But it does sort of point out one of the things that we did in our group that I think is interesting in terms of hacks, like what went wrong, but I don't know if it was necessarily wrong. We all went for things that we hadn't done before. So I've done a lot of SNMP modeling, and that would have been a very easy thing for me to do, but I didn't do that part, and instead Gregor's did that because that was something he wanted to investigate, doing SNMP at the CLI rather than doing like a screen scrape. So each of us went for the most challenging thing that would expand us the most, which I actually learned quite a bit today, and I think everyone did. So in that sense, it was a success. And we actually did get close to finishing. There are pieces. It's a matter of doing a little bit of stitching at the end.
There's nothing much to add, but I'm not a programmer yet in any measured way, so it was mostly kind of a exercise, but I think I did quite well. I was able to get a list of peers from a given device through SNMP and find how many prefixes are being learned and advertised. So I would probably need another few hours to get the data cleaned and ready for them to be parsed.
Thank you. Brandon's got one last thing to present.
That's my phone. I would have found you. I would have tracked you down. Hey, everybody had to do this on OS X too, man.
Okay, my hack is a meta hack. It's a hack about hackathons. So we wanted a way, we were kind of chatting before, we kind of want a way that we could have a master Git repo or some way that people could discover these hacks, not only at this hackathon, but at other hackathons. So I thought, hey, why don't we just throw together a SQL-backed web page? So that's what I have here. HackRego, I don't know. It's a horrible name. We'll come up with something better later on. But the idea here is you have a list of hackathons. So there's one in there today. And then there's a bunch of hacks. So these are just all made up because I didn't have your hacks while I was doing this. We can link to people's code. We can find out the peeps that are actually working on it. I worked with some great teams here. They're superstars. They're supermen. And we can actually click on one of these and get additional information. So I think the next steps here is kind of adding in a voting system, getting this to be cleaned up a little bit more, and any other ideas. So that's kind of why I wanted to present, is I want your feedback. What would be really awesome to put in here? And here, what's something that we can actually have ready in productionist-like stage the next time we have a hackathon. So
Thank you very much.